Hello everyone. In today's video, we're gonna look at the outdoor solar powered security lights with motion sensor. What the product that you're looking at here is Glorious Light branded security light. I think it's a pretty generic product. It's that's marketed under different brand names. You can get it from Amazon for about $53. The lights can put out 1600 lumens of brightness, have a motion sensor circuit. There are a couple controls underneath. One is to set the time the light stays on once the motion is detected, and the second control is to set the sensitivity of the motion sensor. So you can configure anywhere between 10 to a maximum of 72 foot. It can detect the motion at. You can configure anywhere between the product itself has a couple of batteries behind it, and we have a solar panel that to charge the battery. The specification of the solar panel says it puts out 3.5 watts of power, but from the look of it, it certainly looks a little larger than the other 2-watt solar panels that I have seen earlier. So, but I'll test it out and see how much power it puts out. So what I'm gonna do with this today is it's a used product. It's about 2.5 years used, so it's been lying around for a while, so I thought I'll make a video of it today. When I test the product, gonna test it with a reasonable performance degradation that a 2.5 to 3 year used product typically has. As a first step, we will get started with the battery testing. It's got two 18650 batteries. Each one is rated at 1200 milliamp hour. So for the specification, the battery pack, the combined pack, has a capacity of 2400 milliamp hour. The other specification I missed to say is at a full 100% battery charge, the lights can stay on continuously for 15 minutes. I cannot do that testing given that it's a 2.5 year used battery, so I'm not gonna really test if this will at 100% charge the system is gonna light up the area for 15 minutes. That wouldn't be fair to test it at this point. So with that expectations of a used product in mind, let's get started with the solar panel testing. Okay, so here I have the solar panel that I'm trying to run a quick test here just to see how much power it generates and what its voltage and current specifications are. So that one has a connector. I do have a female jack, so I don't want to cut this wire. I still want this to be fully functional to perform some of my other test cases. So I just hooked up a female connector. So now I have access to the positive and negative terminal. So that was my electronic load. So that will can vary the resistance in here so that it'll pull more current. That way we can find out the power specification of the maximum power the solar panel can provide. So let's get this started. I'm just going to connect the electronic load to the main line to the AC power, and let's hook up the solar panels positive to the red and negative to the black of the electronic load. So there I didn't increase the resistance, so right now the voltage that it's showing there is the open circuit voltage. So I'm gonna place the solar panel in such a way that in about a 45-degree angle to the sun for a better sunlight reception. So it is all set up and we can increase the load, how much power the solar panel can provide. Two buttons, there are two knobs here. The one on the bottom will do the fine adjustments, and the one in the top will be a coarse one. So I'm going to start with the fine one, gradually increase the current, see how much current it can provide. So it's right now at 1.9 watts, 2 watts, 2.11 watts, and you can see that the fan kicked in to dissipate the heat. 2.06. Oops. All right, so that is our maximum, 2.11 watt. It can provide 4 volt at 0.53 amps. It's a bright day today. Sunlight is bright and it's about 2 p.m. That's a perfect time. So I'm going to make some adjustments to the solar panel positioning to see if I get better current. 2.1 watts. The open circuit voltage is 572. So let's get to the teardown part of it. I don't think there's gonna be anything exciting happening in these lighting units. There's gonna be a PCB with surface mounted LEDs there. I've looked at similar PCBs before, so I'm not excited to open these light boxes. However, I'm curious to look at what's inside this the base unit, all the voltage regulation circuitry, and I want to look at the motion sensor unit and the components used here. Let's remove the batteries. So if the specification says the battery capacity is 2400 milliamp hour. So that tells me these two batteries should be connected in parallel. So we'll see. Okay, that was pretty quick. Okay, these things are soldered. Okay, the positives are connected together, the negatives have two different wires. I am not sure if one goes to the sensor, if one battery powers the sensor and the other battery powers the light. And there's a set of 3 wires that goes to the sensor. Couldn't see a part number on any one of these. These two look like some kind of voltage regulation chip here, but I couldn't read a thing about what these are. Okay, good. So that's the solar power, solar input. And so I have the switch. There's this thing called B1 and B2. Yes, it's battery 1 and battery 2. All right, so I've hooked up I've connected just the light, and I've disconnected the sensor piece. If it can work even with a single battery, yes. It is truly parallel connected. I think it works even with a single battery. And I don't think, and my theory that one of the battery powers the sensor, the other battery powers the light is wrong. I guess it's just the circuit, that the way they have connected so that they can charge each individual battery in a balanced way. That's probably why they have 2 separate wires from the battery going into the circuit board. But it is a parallel connected battery. So I'm gonna try opening the sensor part. Cool. I don't know the purpose of this thing on the top. I can see the part number for this guy. Whole bunch of screws. I'm sure the assembly had a lot of manual work here. I would expect a snap-on connection everywhere. Doesn't look like there's an easy way. I guess that's the max I was able to get to without damaging this thing. If I want to look at the circuit, I have to break it. There's a small integrated circuit inside. I can see just one of them and some passive electronics like resistors and capacitor I see. But if I want to break this thing. But I do have the part number. That's a good thing. That wasn't the end. So I thought I would get my microscope here and look at the part number. So I was able to identify the part here. I'll put it there in the description in case anyone needs it. NICERA. That ends the teardown of the motion sensor. So that wraps up the teardown of the solar security lights. So I did this for my own learning purpose. I was curious to know the circuits inside the regulates the battery voltage and the circuit that's used in the motion detection block. I hope it's of some use to you. I hope you enjoyed watching this. Thank you. See you in the next video.